ሰላም ተማሪዎች እንደምን አላችሁ? እኔው ነኝ የዘጠነኛ ክፍል ፊዚክስ መምህራችሁ ከሉሲ ብሪጅ አካዳሚ። Today we'll discuss about the fourth section of Unit 1, which we call it is historical issue and contributors of what? Physics ideas or the pointer contributors about the physics basic concepts. So before that, እንደ ሁሉ ጊዜው ማስታወስ ያለብን ዌብሳይታችንን lucybridgeacademy.com የተለያዩ አጫጭር ኖቶችን እና የተለያዩ ጥያቄዎችን ወይም የጥያቄ ባንኮችን እናም ከአምስት በላይ ቋንቋ ያላቸውን የAI መተግበሪያዎችን ማግኘት ይችላሉ። እንዲሁም የዩቲዩብ ቻናላችንን ሰብስክራይብ ማድረግ እንዳትረሱ። በተጨማሪ ሐሳብ አስተያየት ካላችሁ እንድትሰጡን የቴሌግራም ቻናላችንን ጆይን እንድታደርጉን እጋብዛለሁ። ወደ ትምህርታችን in the previous section that we discussed about what is the basic importance of the physics for that of society, the basic importance of physics society, and also what are the fields which are related, what are the disciplines which are related to that of the physics concepts. So by having this, before starting this section, let's do these two questions. So by having this, the first question is the classical mechanics and quantum mechanics, which are different areas of focus. How to classify the quantum and the classical mechanics having that of their focus. So by having this, what does mean by the classical and quantum mechanics? Okay, what does mean by the quantum and classical mechanics? In this case, the classical mechanics the classical mechanics, which deals about what? The motion, the concept of what? The concept of motion and force, having macro objects. This is having that of the kinematical and dynamical. Without of the classical mechanics, the kinematical and dynamical, how a body moves without what? Without force and with force. So by having this, that's the classical mechanics concerned about any object that we can see in our naked eye can move either kinematically without force, and how we can justify the basic quantities, the basic physical quantities which are related about what? The kinematics, and how a body moves dynamically within that of a force add on it, the force applied on the object, the object or the body. So this is the basic question about what? The classical mechanics. Whereas in that of the quantum mechanics, that's it is dealing about what? The concept of motion and force on micro particles. Okay, the microparticles that we can't see in our naked eye. So we can have the idea or the perspective having that of what? The quantum mechanical model, or by having that of the modern physics, by having that the modern theory, the modern physics theory. So by having this, that is how we can classify and differs the classical mechanics and quantum mechanics. I think you have a point, and you got the point. So by having this, this is how we can describe and how we can do classical and quantum mechanics differ in that of what? The area of the focus. Whereas in the second question, how physics foundation to feel like chemistry, energies and medical science, which is helpful for that of what? It is basic concepts, principles, laws, and other ideas which are foundation to what? Other fields or disciplines. So by having this, that of the fields like chemistry, how we can relate it? Like that of the force concept, how atoms or atomic structure or atoms in the nucleus bond together, okay? Within that of the bonding condition, like that of the ionic bond, coordinate covalent bond, the covalent bond, hydrogen bond, and so on. Whereas in that of the molecular structure, how we can differentiate the molecular structure of the atom, and the atomic nuclei, which is basically concerned about what? The physics and chemistry. Whereas in engineering, we have different engineering fields, which are basically about that of the civil engineer to manage the height of the building, the weight of the building, and any architectural design, and different factors which can be managed having that of what? The physics concept. Whereas in that of the other basic concept regarding that of electricity, which is concerned by having that of what? The electrical engineers. You have the idea about how the electrical engineers work with what? The basic physics concept, which is interrelated to that of the electrical engineer. And any other, like that of biomedical engineer, to construct the medical equipments. Then again, here what? In medical science, that physics is helpful for that of treating patients or peoples for different diagnosis by using that of different instruments, different measurements, like the blood flow measurements, like that of the heartbeat measurement, like the stethoscope, and also checking up of the woman's womb to check the condition of the baby, and also to check the fracture of our bone using that of X-ray, to check the condition of the brain having that of MRI, and to check the general all body system having that of the CT scan, computerized tomography. So there are different medical equipments which are used in medical science. So in this case, that physics foundation of fields like chemistry, engineering, and medicine that are basically used the physics concept to have what? The field to sustain. So by having this, these are the basic things you have to focus on. Now let's come up to today's lesson, the first section, how you can see the historical development of physics by having that of different contributors, the pointer contributors. By having this, the transition from that of the classical to what? Modern physics. You have to look at the transition of classical to modern physics. The classical physics develops from what? The Renaissance through that of the 19th century, focusing the mechanics, thermodynamics, and electromagnetism. About that of the mechanics that we classify earlier about that of the quantum and classical mechanics, and how they interpret it and how they formulate different laws by that of the pointer scientists, the pointer physicists. Then after about the thermodynamic at the industrial evolution, that's the uses different physics concept to build an industry, to build factories. And also nowadays the electromagnetic system, the electromagnetism, which is upper-handed or developed very fast, having that of the electromagnetic application in that of different electronic appliances that they use what? The electromagnetic system. So by having this transition of classical to modern physics, that is one of the historical development of what? The historical development of the physics as the basic concept, So by having this in that of the 20th century, that's physics revolutionized the discovery of the market shift of what? Modern physics. The market shift of modern physics. This modern physics, which gives us what? Too many information, two different concepts. To have what? To have too many discoveries and innovations that we are used for that of what? Our daily life activity. So this transformation, which are major advancement on that of what? Technology. Major development on technology. Okay? Which is more major importance to what? The society. To solve problems. And gives a scientific understanding of the universe. That we can understand the universe clearly, because in that of the definition of physics, we have to understand the natural phenomena. To have what? The component, the property, and the process of what? The universe. So by having this, the scientific understanding of the universe, that makes what? Having that of the transformation of the major advancements with that of the technology, society, and scientific advancement of the universe. In this case, the dominant pointer scientists and physicists, which are helpful for that of our basic physics education. Not only physics education, the science of physics concept, principle, laws, theories, and formulas, by having that of the pointer scientists and pointer physicists, like the first one, Isaac Newton, who was born at 1643 and died at 1737. In that of the 16th and what? Were lived in that of the 16th and the 7th century. 16th and 7th century. That's he make the basic three laws of motion and the principle of universal gravitation. That is what we call it is the gravitation, the universal gravitational law. All two masses of a body, which are what? Attracted to each other. By having that of the gravitational law, the force of gravity, which is the same as what? G mass 1 times mass 2 over r square. This is formulated by having that of his theory, that's the force between two masses body, which is directly proportional with the product of the two mass, and inversely proportional with the separation distance square in between what? The two mass. And where G is the universal constant. Here, G is universal constant, which is G is equals to 6.67 times 10 raised to 6.67 times 10 raised to minus 11 Newton meter square per kilogram square. Okay, 6.67 times 10 raised to minus 11 Newton meter square per kilogram square. Where mass 1 and mass 2 are the two masses which are separated by the separated distance r. Okay, m1 and m2 are two masses where r is separation distance. So you have to consider this is what we call it is the universal gravitational law. Whereas the three laws like that of the law of inertia, the law of acceleration, and the law of action and reaction. So you have to you have to have the ideas regarding that of what? These things. Okay? And you will explain this on the next chapters. And here his idea laid in the foundation of the classical mechanics to explain the terrestrial and celestial motion. Not only that of the Earth's surface, but also he explains different the celestial bodies, the astronomical motion evidences that he gives an explanation. So by having this, Isaac Newton contributes to many things. And also he was a key figure of what? The scientific revolution. And that of the 60s and what? 7th century until his death. So by having this, he was the pointer physicist who can manage what? The basic four laws that of the three basic laws: inertia, acceleration, and action and reaction. Whereas the other one is the universal gravitational law. The universal gravitational law. And the second one is Michael Faraday, who was the pioneer contributor of what? Contributor of working about the electromagnetism. So in that of the electromagnetism, in 1821, Michael Faraday demonstrated the mechanical motion using that of what? Magnetic and electric current. That he invent the first electric generator by converting the magnetic force into electric force. The magnetic force into electric force. That he also demonstrate what? He also demonstrate a simple motor on his experiment. To check the motion of a given body to examine what? The generation of electricity having that of the electromagnetic effects. So by having this, that's he also pioneer for that of what? The motor action. So by having this, that's he invents a simple electric generator by converting the magnetic force to electric force. And he was a discovery of what? A fundamental to the field of electromagnetism and modern electronic technology or electrical technology. For that of the modern electrical technology, he was the fundamental key role to have what? The basic concept for that of the fundamental to that of the field of electromagnetism and modern electrical technology. And the next one is a person, an English physicist whose name is James Prescott Joule, in the 18th century, who was the revolutionary of the Industrial Revolution, who discovers the relationship between heat and what? Mechanical work. That's demonstrate about thermodynamics. Who explains more about thermodynamics. Which is one of the branch of physics which is about the property and the conservation law of what? The conservation law of the mechanism of heat transfer, which is converted to what? Work done. Mechanical work done. How we can convert the heat energy to what? Mechanical work done. That of the simple engine system, on that of the given industrial engines and also the car engines, which converts what? A mechanical work done to the heat work done. The heat to what? Mechanical work done. A given fuel to what? Mechanical work done. So his finding is to that of the formation of law of conservation of energy. This law of conservation of energy, which deals about thermodynamics. That is what we call it is the law of conservation of energy. And James Pascal Joule's work was the foundation for that of the first law of what? Thermodynamics. Describe the energy transformation. And that of the first law of thermodynamics, which we also call it what? The law of conservation of energy. That's why, as I said, that's James Pascal Joule is the pioneer physicist who tried to manage the conservation law of energy. By converting the heat energy to what? Work done. And the other pioneer physicist, who was a female physicist, who was the first female to win the Nobel Prize. Okay, the outstanding and the international prize. By her contribution. So by having this, she was the German physicist who called the Marie Curie, pioneer researcher. That's pioneer researcher that's on that of the radioactive and known as what? The mother of modern nuclear physics. The mother of modern nuclear physics. She discovered the element of polonium and radium through what? Her experiment. Her experiment. She works the discovery of what? Polonium and radium through her experiment. This experiment makes her what? To win the prize. To win the prize. So she were a very intelligent female person in our world. In our world. Her contribution were advanced to the understanding of what? The atomic structure and radioactive decay. How we can date the atomic level of what? A given matter. A given matter. By having that of what? The radioactive decay. The radioactive decay. So she works to enough thing about what? About science of nuclear physics. The science of nuclear physics. And at last, the pioneer physicists who make the world more visible were what? Albert Einstein, who were the contributor to that of what? Our modern world, the modern physics, who was a pioneer of what? The modern physics. Albert Einstein developed what? The theory of relativity, which is redefined the concept of space, time, and gravity. And that of space, simply, okay, length, height, for example. Height. For example, for your sense, for your understanding, in that of the height, when you have a friend near to you and you place him at the ground and go to at the 10th floor and look at your friend, then your friend looks like small. Means in Amharic ለምሳሌ ጓደኛችሁን አብራችሁ ያለ የምታውቁት ጓደኛችሁን 10ኛ 11ኛ ከፍ እያላችሁ በምትሄዱበት ጊዜ የጓደኛችሁ ሳይዝ ምን ያደርጋል? ይቀንሳል ወይም ትንሽ ይመስላችኋል። This is why we call it the theory of relativity. ስለዚህ በዚህ አይነት መንገድ አንስታይን በጣም ብዙ የሚባሉ የሪላቲቪቲ ህጎችን በተለያየ አይነት መንገድ አስቀምጧል። Without of the space relativity, without of time relativity, without of gravity, okay? Center of gravity law. So he can explain different things regarding that of what? The concept of space and time and gravity. We're having that of his theory of relativity. His work were significantly impact on that of the classical and led an advancement of the modern physics. That's that of he lies what? An impact on that of the classical mechanics and led to have what? The modern physics theory. So he was a basic contributor for the development of quantum mechanics and revolutionized the theoretical physics. And the next video will summarize the physics and human society that we discussed earlier on this 4 videos. Don't forget to subscribe our YouTube channel and please try to join our Telegram channel. For now, thank you very much.